Hey everyone. Last week we looked at calculations that would be used if research compared differences between two independent groups. This week we're going to be looking at calculations that are done when the research is comparing dependent groups, also known as paired groups. So let me go ahead and start sharing my screen right away. As usual, it takes me a minute to get that accomplished. All right, we'll get right into SPSS so you don't have to look at the funhouse effect. Okay, so paired data is a natural two-point event, like usually a before and after sort of a thing, or a time one, time two, where there's an inherent logical link between the data points. So like in the example of the before and the after study, each individual participant represents a paired data point. Each one has a before value and an after value. We still have a dichotomous variable, but this time it's split by the two sides of the paired group. And if we continue with the before and after example, the before a treatment and the after a treatment represent the two possibilities for the variable. We have similar assumptions to the ones we talked about last week. We're still going to run our descriptive statistics. We're still going to think about, normal versus abnormal distribution of variable, types of variable, variance, random sampling, sample sizes, things like that help us make our choice as to whether we will use the parametric test or the non-parametric test. But I'm going to walk you through both of them. So for our example this time, the parametric test is called the paired samples t-test. You also might see it referred to as the repeated measures t-test. Okay, again, we have one group of people. We'll collect data from them on two different occasions or under two different conditions. We're going to use an example research question that looks to find out if there's a significant change in participants' fear of statistics test scores following their participation in an intervention designed to increase their confidence in their ability to successfully complete a statistics score. So does this intervention have an impact on their fear of a statistics test score? The participants are going to take the fear of statistics test before and after the intervention. So here you're going to have one set of participants and two variables. You're going to have one categorical independent variable, time one and time two, or before and after, and one continuous dependent variable, the score on the fear of statistics test that is measured on two different occasions. This test is going to tell you if there's a statistically significant difference in the mean scores for time one and time two. So we're going to start by opening up our data set. And this one. Okay, this one is experiment. Okay, and let me take a minute and point out that even though in this case we've got the option of sex, the project that I've just described to you, we are not going to distinguish between males and females in this study. We don't care. So don't be sidetracked by having extra information. You don't need to do any grouping by males and females in the way I presented it. All we care about is the before the intervention and after the intervention. Okay? So we're going to start by choosing analyze and then compare means, and then we'll go to the paired samples t-test. Okay? Then we're going to choose the two variables we want to compare. So we've got fear of stats time one, and we've got fear of stats time two. Okay, we move them into the paired variables box. Then we click OK, and we look at the output. Okay, in this table, the paired samples test. Whoops, sorry, got to the wrong table. You look at the last column called significance two-sided p. This is your p-value. If it's less than 0.05, you can conclude that there is a statistically significant difference. Okay, so what we see reported here is less than 0.001. Our table rounds to 3 places, and we can't really ever say 0. We don't know exactly what it was, but we know it's considerably less than 0.05. So we can conclude that there is a statistically significant difference between time 1 and time 2. We also need to note that there's a t-value of 5.39 and degrees of freedom, that's what DF stands for, of 29, which we're going to report in our presentation. We'll also note the mean difference of 2.67, rounded to 2 places, of course, 95% confidence interval that stretches from a lower bound of 1.66 to an upper bound of 3.68. Okay? Now that we know that the difference is significant, we need to find out which set is higher. So we look at the output box paired sample statistics up here to find the mean scores for each set. So the time for mean 1 was 40.17. I'm sorry, the mean for time 1, I said that backwards, was 40.17, and the mean for time 2 was 37.5. We can conclude that there was a decrease in fear, right? After the intervention, their fear decreased. Now, it's important to remember that even though we can show that there was a difference in the scores, we can't prove that the intervention caused the decrease. There are many factors that could have impacted the scores. They're known as confounding or contaminating factors. Good researchers will do all they can to anticipate and control for those factors, or even incorporate them into research design. But the reason that I bring this up is that you just need to beware that you don't use the word prove. And if you hear someone or read research where someone says they have proven research, that you remain skeptical, because the most we want to say is we've been able to support our alternate hypothesis. We've been able to reject our null hypothesis. And even though we've determined that the difference was unlikely to occur by chance, we still don't know a lot about the magnitude of difference. One thing we can do is calculate an effect size. Now, SPSS doesn't give us this in the output, but there are websites that can help you do this. You're certainly welcome to Google those if you like. When you read research done by others, you might run into either something that's called Cohen's d or the eta squared effect size, that's ETA. For Cohen's d, 0.2 is a small effect, 0.5 is medium, and 0.8 is a large effect. For eta squared, 0.01 is a small effect, 0.06 is moderate, and 0.14 is considered a large effect. I can just run you through really quickly. If you wanted to do eta squared in this case, that's when you take the t-score, which I said right here, square that, and then divide it by n minus 1. So in this case, you would take 5.39, square it, and then divide that by 5.39 squared plus 29, right? N minus 1. So that would leave you 29.05 divided by 29.05 plus 29. That leaves you with 0.5. We've already said that that would be a large effect with a substantial difference in the test scores gathered before and after the intervention. So let me show you how you would report that in PowerPoint slides like I did last week. A paired samples t-test was conducted to evaluate the impact of the interventions on student scores on the fear of statistics test. there was a statistically significant decrease in FOST scores from time 1, where you've got the mean and standard deviation, to time 2, mean and standard deviation, where you talk about the t-score with the degrees of freedom, the p-value, and we say the mean decrease was, we talk about that value with 95% confidence interval, ranging from here to here. If you calculated eta squared, you can put that in there. That is not required. So that's just on there for you to know about if you run into it with other people's research. Okay, now we go back to our data. Okay, now let's say you did your descriptive data, you did your decisions for parametric, non-parametric, and decided that you, in fact, needed to run a non-parametric test for this week. That would be called the Wilcoxon signed rank test, sometimes called Wilcoxon matched paired signed ranks test. Long names. We just call it Wilcoxon, okay? Instead of comparing the means used in the repeated measure t-test, it's going to convert the scores to ranks and compare them at time 1 and time 2. So to run this test, we're going to open the program and the data file. We've already got it going here, so we're going to click on Analyze. Then we'll go down to Non-Parametric Test, and in this time, we're going to go to Legacy Dialogues, and then we're going to go to Two Related Samples. Then we're going to, we've got Sphere of Statistics time 1, move it over, Sphere of Statistics time 2. Just so you know, you can hover over here and see what you need to see if you aren't sure if that's the right variable. Okay, move it over there, move those into the test pair. Then we make sure Wilcoxon is checked. Under options, you want to have quartiles selected. Continue, and okay. And here's your output. Okay. We first want to look at get it down here, the z-value and the associated significance level, which is right here. If this significance level is equal to or less than 0.05, you can conclude that the difference between the scores is statistically significant. Here again, we have less than 0.001, so these scores are statistically significantly different. The effect size can be calculated using the same sorts of things that we've been talking about last week, that we talked about earlier today. You can Google those. I'm not requiring you to do these in class. You won't be asked to do that. I just want you to be aware of what that means if you see it in someone else's research. And if you were going to write this as if you were publishing it, again, which is what you're asked to do in your homework, let me show you what that would look like. A Wilcoxon signed rank test revealed a statistically significant reduction in fear of statistics following participation in the training program. Z negative 4.18, P less than 0.001 with a large effect size. The median score on the fear of statistics scale decreased from pre-program median of 40 to post-program median of 38. Now that we've covered studies that compare two groups, we'll be moving into studies that compare more than two groups and the analysis of variance. One thing that I'm going to stop sharing my screen really quickly. One more thing that I wanted to point out to you is that you are not always going to have the PowerPoint slide examples like I've shown you these 2 weeks. Giving you an example of how to write up your findings like you would find them in research for your homework, but you're always going to follow that same format. You're always going to say, give a generic overview of what you were looking at, what you were trying to find, what test was run, what your p-value was at a minimum, and the conclusions you drew based on that. You're welcome to include more information than that, but at a bare minimum, that's what we're going to need to see. Okay? Thank you.